Right, in the previous class, we have talked about the basicity of different amines, okay, by looking at the availability of the lone pair on the nitrogen atoms in all amines, how how easily they can be donated, okay, to accept proton, okay, to a proton. So we learn this order. So today we are not looking at the these kind of properties anymore. We are looking at the reactions. Okay, first will be how do we prepare different types of amines. Now there are two types of amines that you can prepare. One of them is the one without benzene. Okay, so we look at how to prepare this type of amines first. Then later, okay, we look at how do we prepare phenylamine. Now, preparation of amines, you have learned all these reactions before. Some of them are in AS actually, which is this one, halogenal alkane with ammonia in ethanol. This was in nucleophilic substitution of halogenal alkane in AS organic chemistry. But now it appeared again because we are talking about how do we use reactions to make amines. Okay, halogenal alkane will react with ammonia in ethanol, and this Br, halogenal alkane, the Br will actually replaced by NH2, amine group. So can you see that amine is actually being produced here? Okay. Now, so what are the reagents to be used if we want to turn halogenal alkane into an amine? Ammonia in ethanol, right? Okay. Important, it must be in ethanol because if you use aqueous ammonia, the OH hydroxide ion from water will actually turn halogenal alkane into alcohol instead, then you won't get amine, right? So use ammonia in ethanol. Condition also very important, not just any ordinary, just heating. Okay, must heat under pressure. So you get amine. Right, the next reaction to convert something into an amine will be reactions of nitrile with hydrogen. Okay, this is reduction of nitriles. So if you cannot remember, nitriles are compounds with C triple bond N as the functional group. So this C triple bond N, it reacts with hydrogen, and this hydrogen from the reagent will actually make this part saturated. See, just now you have C and triple bond, right? Now no more triple bond, all single bond. This carbon is bonded to the R, bonded to two hydrogen, bonded to the N. Initially, this carbon has only two sigma bond, now four sigma bond. Whatever that, whatever unsaturated just now, okay, you just have to add a maximum number of bonds to the carbon and then you add hydrogen. So at the end, you see we get an amine. Same goes to nitrogen. Nitrogen is always forming compounds with three bonds. So this nitrogen, initially only this triple bond, right? One sigma bond only. Now it has three sigma bond in the product. Okay, we bonded to H, bonded to H, then bonded to C. So three bonds. So just make this compound saturated. And how? Okay, just add a lot of hydrogen to the compound until every atom has maximum number of sigma bond. Now can you see that even if nitrile is bonded to a CH2 from the benzene, they're also the same thing. It will be converted into an amine. Now there's another reagent that we can use to reduce nitriles to amine, which is this LiAlH4. Just now we were talking about using hydrogen and nickel catalyst. Second reagent to turn nitriles into amine will be LiAlH4. You get the same products. So from there, unsaturated became saturated. Now your syllabus already mentioned that you only need to use LiAlH4, so I'm going to cancel this dry ether. Okay, this dissolve in this combination is not required anymore. You only need to give the main reagent here, which is the LiAlH4. Okay, right? So this one is new to you. Okay, you haven't learned this one yet. Just now, reduction of nitrile, nuclear phase substitution of halogenyl alkane. You have learned them before. You've seen them before in AS organic chemistry. Now this is new, okay? Which is reduction of amide. Now I think I already told you about amide in one of the previous slides. Amides are compound with the functional group of C double bond O, okay, and NH or NR. Okay, so this is an amide. Now this amide can also be reduced to form amines. C double bond O will be gone. Okay, the O will be reduced. So what do you do is this carbon here now has two hydrogen in the products. Okay, two hydrogen. So this O is gone. Again, we use the same reducing agent, LiAlH4. And look at the products, okay, you now have R, then nitrogen bonded to hydrogen or R groups. So can be primary, secondary, or tertiary amines, depending on how many R groups, how many alkyl groups is bonded to the nitrogen in this product. Yeah. So I've written here if R, okay, if these two R are hydrogens, okay, then you will have primary amine as the product. If one of them is alkyl group, okay, including this alkyl group, it will be secondary amine. If all three of them are alkyl groups, then you have tertiary amine as the product. More examples given here, and again, I need to cancel this dry ether. It's actually just a solvent that is used to dissolve LiAlH4, used to appear in the mark scheme, that's why I included, but now no more. They only want you to know LiAlH4 as the reducing agent. Okay, so just now we were talking about how to prepare amines without benzene. Okay, now this slide is focusing on preparation of phenylamine. Okay, so phenylamine means the amine group, the NH2 is directly bonded to a benzene. Okay, so the structure will look like this: benzene and H2. Okay, just now, okay, if you look back at the previous slides, you are not preparing any amine with NH2 directly bonded to the benzene. Okay, now we are talking about those, okay, NH2 directly bonded to the benzene, phenylamine to be exact, that's the name of the functional group. So to prepare phenylamine, we need to use a very specific method. Okay, we cannot follow the method used to prepare the aliphatic amines. So we must start with nitrobenzene. So it's a reduction of nitrobenzene. Yeah, NO2 bonded to benzene is called nitrobenzene. Yeah, we have seen this in chapter 25. Okay, have not seen it for a while. This is already chapter 27. Nitrobenzene, the N has two oxygen. So at the end, you see, okay, no more oxygen, they all turn into hydrogen. So it's a reduction. So what kind of reagent should we use? We use tin with concentrated hydrochloric acid. It is common here, followed by sodium hydroxide solution. Again, yeah, tin with concentrated sulfuric acid, followed by sodium hydroxide solution. So why do we need to use followed by sodium hydroxide solution? Because tin and concentrated hydrochloric acid will actually turn nitrobenzene, okay, to an ammonium salt, NH3 plus here. Why ammonium salt? Because there's a lot of acid here. But remember, we want to get phenylamine. We do not want NH3 positive, we want NH2. So what can you do is you follow by addition of sodium hydroxide solution to neutralize this part, to actually accept the extra proton from the solution. So once no more extra hydrogen ion in the solution, this ammonium ion will be turned back into phenylamine. That is the reason why followed by sodium hydroxide. Of course, okay, this reaction has high activation energy because you see you're breaking NO bonds. Therefore, you need heating to provide the energy. So sometimes in the question they will say hot, thin, and concentrated hydrochloric acid. Means okay, use this reagent and then they heat the whole mixture. That's why it's hot. So to write an equation for this reduction, you can use square bracket hydrogen to represent hydrogen from reducing agent. So you see, you're turning NO2 to NH2. So where did all this oxygen go? Okay, they form water with H also. That is why you need 6H. To turn NO2 to NH2, you only need 2 hydrogen, right? So why do you need 4? Because, okay, sorry, why do you need another extra 4 hydrogen? Because you need to turn oxygen into water also. So that would be preparation for amines, aliphatic amines, and also aromatic amines like this, phenylamine. Some from AS syllabus reactions, some are new. Okay, remember all the reagents.